So hello everyone, and today we'll be seeing one of the problem from Geeks or Geeks. It says P to tile a floor. The problem is quite interesting and it is intended to scratch your brains for a while. It says given a floor of dimension 2 cross n and a tiles of dimension 2 cross 1. The task is to find number of ways the floor can be tiled. A tile can either be placed horizontally, that is 1 cross 2 tile, or vertically 2 cross 1. So either you can take vertically or you can take horizontally in such a way. And note, two tiling arrangement are considered different if placement at least one tile differs. So in this way, this tile and this tile differs. It comes over here. That is the reason it is different in arrangement. So let's quickly jump to an example. So we have 3, that means 3 cross 2 or 2 cross 3, sorry, my bad. So 2 rows, 3 columns, and we can either place 3 of them vertically or in such arrangement or in such arrangement. Nice. So in 4, it's in such a way. So when we have n as 4, that means 2 cross 4, there are 5 different ways. You can visualize this in 5 different ways. And when it comes to 2 cross 3, there are 3 different ways. Now initially the problem looks quite complex. When you give it more attention, things become much more clear. So now let's assume that we have 2 cross n tiles. I am not taking any fixed number over here, but I am taking in general. So you see, we have tilings in such a manner that we should place here, here. When I am saying, okay, I will just denote empty spaces with star. So this is 2 cross 2, 2 cross 3, 2 cross 4, and so on. So while dealing with such cases, we can imagine either we are going to place this in a way like either we are going to have a vertical arrangement like this, or either we are going to have a horizontal arrangement like this. Maybe I will just take this looks much better. Okay, nice. Okay, enough of formatting. And when we are doing this, we can go ahead and we can take next into picture. So what I'm saying is, if I'm having that fill method in such a way that I'm using it in a vertical fashion, I'll say populate in vertical fashion, then I'll need to go ahead with fill rest again, and I'll also need to do populate in horizontal fashion, then fill rest again, and then I will sum up the both. So this is somewhat which comes into mind when we are dealing with such kind of problem. Again, this is a recursive call, and this again is a recursive call, because we are going to fill it again, and our primary function was doing the job of filling. So yeah, this is what somewhat it looks like. Still we are not concrete upon idea. So how shall we proceed? So let's dig down further, that even if we go ahead with this idea, there are multiple overlapping approaches. So you see, when we are dealing with filling this area, if I'm going ahead with filling up of this vertical space, you can see that here I am again coming across a square which consists of one vertical or one horizontal possibility. What do I mean by possibility? That I can place 2 verticals or 2 horizontals in such a way, 2 horizontals in here two verticals are in here. So here we can deduce it once we understand how we are moving. So let's trace how do we move. So one thing comes into my mind that hey, if I'm moving vertically, so what is my position then? If I'm moving vertically and everything is good, like I am proceeding in a way where it is possible to put a vertical tile, which is almost possible if there exists a space, then I am moving I vertically. Then if I am placing at ith position, I am moving to I plus 1 position. Mind here carefully, if I am placing it over here, I am moving one step forward. So let's check it how about horizontally. So if I am placing at ith position, I am moving to I plus 2th position. So if I am placing it as 0, 1, I am placing it over here, I am moving it to the plus 2th position from the initial. And this is where the entire crux of the problem lies. You see, now when I am going back and taking our initial way, how can we solve this problem is either we can have, so let's say if I am having a tile of size 1 cross 2. So how many ways do you think you have? As usual, you don't have this and this. So we have only one way of dealing with this. So let's say if we have 2 cross 2, so this and this. So we have two ways of dealing with this, because either we can deal with like this, or we can deal it with in this fashion, vertical fashion. No other combination is possible here. And if you go ahead with 2 cross 3, then we have again yet another space. And here we do, what do we do here is we consider placing verticals plus horizontals. So placing verticals and horizontal means taking one step back and 2 steps back. So considering I minus 2 plus, verticals, right, I minus 1 way of I minus 1 plus way of I minus 2. So this is very similar now, and I guess most of you have clicked the pattern right here, and hence we got the solution as 3. What if we have 4? Let's take this and this. If we have 4, we took one step back plus 2 steps back and sum it up. So 3 plus 2 is 5, and let's check our answers. For 2 cross 3 we have 3, yes we have 3, and 2 cross 4 we have 5, and yes we have 5. And this is how we are going forward. And if I am not mistaken, this is what a Fibonacci sequence looks like. Now you know how we can compute. Now how do we implement this Fibonacci sequence? You can go ahead and create a program for Fibonacci. In a recursive manner, it will again go ahead and take 2 to power n, but smart people knows who follow me or are subscribed. If you're not, do it. So they know how to compute Fibonacci in O of n's time complexity and with O of 1 space complexity. So with that thing in mind, let's go ahead and quickly do it with int, or first of all a check, basic check. If n is less than or equal to 3, return n, because basically it's what it is having, it is returning that only. So int a is equal to, or int previous equals to, what it should equal to is 2. If I am starting from 4, int previous should equal to 3. If I am starting from 4, and for int I is equal to 4, I is less than. Remember that prior to 4 we have tackled the situation for I2 over here. Less than or equal to n and I plus plus. And since we are having this situation over here, also store result. Okay, anyways, so what I'll do is int x is equal to, it's a temporary variable x, it will store previous plus previous, and we will then upgrade each one. So previous is equal to previous, and our previous equals to this new number x, and ultimately we'll return the value of previous, which would be updated with this. So far so good, right? Let's compile this one to check for any compiler errors. It seems not, but still it's better to double check. Yeah, it seems not. And let's submit this for rest of the test cases. Yeah, it was fast, simple. So as you can see, this was very simple problem, but it took a while. And within the topic tags, you can see Fibonacci and you can see dynamic programming and recursion. Of course, recursion you can go ahead and do it, but it will take time complexity and space complexity. Even if you optimize the space complexity, even if you optimize the time complexity with memoization or any other tactics, it will yet again take space complexity. So in my opinion, this is the best solution until and unless you have any other solutions, like computing Fibonacci in log of n times. And if you wanted to know about that, stay tuned, because soon I'll be having a video upon that. So for more such awesome content, click the video on your right, and I'll see you in the next one.